Hey everybody, welcome to another video in Math 1332, section 3.3 and 3.4, truth tables for negation, conjunction, disjunction, conditional and biconditional statements. Right, so first, the truth table is the diagram or table to show a compound statement is true or false based on the true values of simple statement. So we showed a compound statement is true or false based on the true values of simple statements. Right. So look at this. If we have the statement P, then the statement not P is going to be negation of P. So if it is true, and then negation of true is false and negation of false is true. So true and false interchange. Right. So that's easy. The negation is just true to false and false to true. Right. Now the conjunction. By the way, for this, just going to list every possible way of the values of P and Q can make up. Right. So let's start. For P, we can have true or false, and for Q we have true or false, but this time the each corresponding values of the first statement we can choose true or false for the second statement. So with that we're going to have true true, true false, false true, and false false. Those are the four criteria. Of course, if we want another statement, for me we split into two again. Now what I want to pay attention is the last one is true false, so it's alternating, and then the next one is alternating every two. And now pretty much that's what we have. So I will go with true false alternating here, and then before that it will every two of them will be every two is alternating for every two. Right. So that's how we make the list all the scenarios for the simple statements. Right, next, I just want to see the logic of one example. I see like this. In order to be registered for the selective service, it has to be male, that is between 18 and 25. Well, selective service required to have both of them, so it is only if you apply for selective service, you have to be a man and between 18 and 25. So in this case, if this is true, both of them have to check. And then if both of them are checked, we can go to a selective service. So in that case, the conjunction. Now let's be clear here. Conjunction we mean is the upside down, which mean the end. Right. And we say, so in this case, it is true when both of them are true and false everywhere else. So technically, if you only check one or two boxes, you will not be in the selective service registry. Right. Now, so to memorize this, what we say is, we're going to go with this. It's true when both are true and false everywhere else. So write this little note. Conjunction is true is true when both of the statements, simple statements, are true. So conjunction is true when both simple statements are true. False otherwise. So that's what we have. We'll do a lot of example later. Right now, just go over the important things here. Right, next. Same thing, alternating on the last one, and then alternate with every two a column before that. Now, I'll give another example here. So let's say in some certain type of cruise ship has this policy, if you want to get on the cruise ship, you have to show the proof of vaccination, or you have to get COVID at least 14 days ago. That's it, that just make those up. So in this case, all you need to do is check one box, then you should be able to get on the ship. So you can have this first one, second, or maybe both. But if you do not check one or the other, that form, that means that person, if you have one of the two, you can go on a cruise ship. If you don't have anything, then you cannot. If you don't have proof and you are not getting COVID 14 days ago, that case you cannot get to cannot get on a cruise ship. So for the conjunction, that's what we focus on. True when both are true. Now disjunction is the V keywords or. Now we have the similar thing here. Disjunction is false. When both simple statement are true, false, sorry, true otherwise. So once again, this is false when both are false. Focus on this. Everything else is true. Right, so that is disjunction. The next, the conditional, is a little more difficult. Our conditional statement, which statement sometimes called the implication, consists of two. So it's if and then. So once again, we're going to have true, false, true, false, true, true, false, false. Now we do the implication. Right. Now a little less intuition. If we start something like, for example, if I say, if I'm a 7 feet tall, then I will play in the NBA, for example. So usually those type of things, when the first statement, the first part of it is not true, then it doesn't matter what to say after that, we're always true. For example, if I am Superman, then something, something, something. That whole thing is going to be true because the first one, the if statement, if I am a Superman, of course it's not true. In that case, whatever, doesn't matter what you say after that, it's always true. So if the first one is false, doesn't matter what it implies, it's always true. So if it's false on the first one, it will be true. Yeah, it's going to be true. The only case is false is where you have true implied false is false. Everywhere else are true. So we say true implied false is false. Are true otherwise. Biconditional statement is really just two statements, and both of them are conditional statement. So this is once again all the different scenarios: true, false, true, false, true, true, false, false. Now they are equivalent if they are the same true values, pretty much. True, false, false, and true. Right. So the conditional and biconditional statement are a little more difficult, but keep in mind that if we start with something false, the whole thing is going to be true. It is only false if we start with something true, implies something false. That will be false. Otherwise, it's true. Right. So let's look at the table here. So construct the true table for the statement. This one. So we have P and Q. So there are two simple statements, and then we have the operation, the negation first, and then the or. So those are the three operations. Right. Two operations. Sorry. Negation. The or. Right. So we make this table here. So we have P, Q. Right. Next, when we see something like this, it's always negation before everything else. So I'm going to put this first. And then not P or Q. Right. Now we leave all the scenarios. True, false, true, false, true, true, false, false. If we leave like that, if we give like this, there will be no overlapping between the cases. Right. Now, not P. Not P meaning opposite to this. So, if we have true, opposite will be false, false, true, and true. And finally, we have the relation between these two columns. So this is an or, right? So when it's or, we watch out for when it's false, when both of them are false. Yeah. So we focus on that, and this is the or. It is false with we have different things. It's going to be true here, true, and true. Right? So this is a true table for this operation. So first we need to look at how many simple statements we have, in this case P and Q. And then we do the not P, which is the complement of P. And then that together with Q. And so that's what we have. Right. Next, I'll construct the two table for the following statement for that. So I have P and Q, two simple statements, and then we have the not, the implication, and the not. Right. So So P, Q. Right. Now, as far as operation goes, it's always a negation first and everything else. So in this case, we have the negation of Q, and then the implication of P implies not Q, and finally, we have the negation of what we just have. Right, let's just fill the table. True, false, true, false, true, true, false, false. Right, now, the first one is not Q. So whatever we have for Q, it's just going to turn to opposite true values. True is going to be false, false is going to be true. So that's what we have. And then next, P implies not Q. So P implies not Q. So the implication or the conditional statement is true implies false, true implies true, false implies false, false implies true. So in that case, you remember that when we talk about the conditional statement, it will be true if we start with false. It's going to be true automatically. And it will always only false if we have true implies false. Right. So if P implies false, it's going to be false. Now put them together. Finally, this is a negation. So just turn everything opposite. True, false, false, and false. Yeah, so we do P implies not Q, and that is only false when we have true implies false, and then we turn all of that to opposite true values. And so that's what we have. I'll construct the two table following. So we have this example. There are 3 simple statements. So how many do we need? How many do we need to make a true table? Well, let's start again. So for the first one, it can be true or false, and it doesn't matter what it is. The next one could be either true or false. And then the next one, just true and false. So now let's just try all different scenarios. True, true, true. True, true, false. True, false, true. And true, false, false. And now we start with false. True, true, false, true, false, 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 true, and false, false, false. So that's all the different scenarios. And for every time we go a step further, we're going to double the amount of scenarios that we have. Now let's focus on the last one. True, false, true, false, true, false. That's easy. The next one, it will be alternating every 2. And even the last one, alternate every 4, 4, 3, 4, 4. The next one could be 8 and 8, but probably will not get that far. Right, construct the 2 tables, so we just make a table. Right, 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have P, Q, and R pretty much. Right. Now we do inside the parentheses first. Q implies R. And finally, the last statement. P Q implies R. Right. So there are three simple statements and then two operation, the OR and the implication. Right, now let's put all the simple statements first. So we start with true, false, true, false, true, false, and true, false. And the next one will be alternate every two. True, true, false, false, true, true, and false, false. The next one will alternate every four. 1, 2, 3, 4. 1, 2, 3, and 4. So those are 8 different scenarios because we have 3 statements. So 2 to the third power is 8. So 8 different statements. Right, now first Q implies R. So the implication is very important that, right, let me do the compare and contrast between the two. The conjunction, disjunction, it doesn't matter the order. We have true and true, or true or false or true, the same thing. The implication, that is not the case. For implication or conditional statement, when true implies false is false. Notice in that direction only, a true statement in the if, and then the statement else is going to be, if and the statement then is going to be false. So keep that in mind. When we look at this, if we have a true implies false, remember it's Q implies R. That's why we have to look in this direction. To be very careful with this. Q implies R. True, it is only false if we have a true implies false. So this will be false here. Because if you have a true implies a false, it's going to be false. If we start with false, it's going to be true automatically. So true and true, that's easy. True and true also the same. Now this is also false. Once again, if we have a true implies false, it's going to be false. And doesn't matter for the if statement, if it is true, doesn't matter what you say after that, it's still true. Right, and because this is true, so that's what we have for the table. And then finally we have that result with P. Right, so I'm just gonna do this. Right, so in the OR, it says it's false if both of them are false. So false and false, both of them are false, and that's pretty much it. It's true when both are true, or just one of them is true, is also true. Yeah. So once again, the implication is false. If you have a true implies false, so true implies false, true implies false, everything else is true. Right. And then finally, false implies true. Like I said, if you start with false, it's going to be true and true. Right. Once again, let's take a look at this. True and true, true or true, true, true or false, true. That, and this, one of them is true, so this true. And it's false if we have negation of P, negation of Q. But if both of them are false, then the OR is going to be false, everything else is going to be true. So that's the true table for that scenario. Right, next, the order operation is negation and then conjunction or disjunction and then conditional, biconditional. So pretty much if we have 3 statements, that we have 8 different scenarios, and then we're going to do inside first, and then the conjunction, and then the complement. Actually, let's make a table. We go one by one and get it when we got there. Now I'm going to run 7 lines. I mean 8. Right. 1, 2, 3, 4, 5, 6, 7, and 8. So P and Q and R. So we can always do that first. Different scenarios for each case. So I do it exactly like I did before. True, false, true, false, true, false, and true, false. How do we know when we stop there? Well, this is 3 simple statements. So 2 to the third power is 8. So that's what we have. Right, Q, alternate every 2. And now the first one, alternate every 4. Right, now we construct the 2 tables. So first, we see inside the is Q implies R. Right, so Q implies R. It's only false if we have a true implying false. So that's one, doesn't matter. Doesn't matter what we start with. If it is false, doesn't matter what we have for the second statement. It will be true regardless. And false implies false. Like I said, if we start with false, it will be true. So it will be true, and this is going to be false because we start with a true statement. That coupled with not with false, so true implies false is false. So remember, this only go from here to here, from the second to third column. Right, next, false. If false, then true. That is what will be true, because if we start with false in the if statement, doesn't matter what you say after that, it will be true. And so the implication is only true. I'm sorry, I should say it's only false if we have a true implied false. Everything else true. Right. So we're done with that. Next, we're going to do the negation, because as mentioned all the operation earlier. So meaning that this is going to be negation of P. So pretty much whatever P is, we're going to turn that to opposite. This is for P, right? So this is just not P, it's a complement of P. So if we start with 4 true, it's going to be 4 false. And then 4 false, it's going to be 4 trees. And then finally, we do not P and conjunction with Q implies R. So pretty much what we have is the conjunction between the not P or Q imply R. So pretty much we compare these 2 columns. Right, so this is going to be and it's true when both are true. It's true when both are true. True when both are true. So we have not P and Q implies R. So we're talking about this, and it's only false. I should say it's only true if both of them are true, then the compound statement could be true, right? For this, if not P is going to be false, And now we do the conjunction with Q implies R, and this we say it's only false when both are false, but we don't have that. So next best thing is just construct the values directly. So this is n, and n is true when both are true, but we have different scenarios here. So it will be false, false, and false. So this is n, and we have both of them for it to work. I mean, both of them true and true. I mean, a true implies false is false, so we need that. And we do have all three. False implies, like I said, if we start with false, doesn't matter what it is, so always be true. Right, so that is the table for that scenarios. Once again, we list each simple statement and give all of the possible outcomes, and then do each operation one at a time, and then at the end, we just have the true table for that operation. Right, so now just quick review, but this time we have just the values. Right, compute the following true and false. So when we look at this, the first thing we do is, because inside the parentheses, true implies false. Well, that's going to be false. Right, so true implies false. That is false. Implication is false if we have a true implies false. That is the only case for the conjunction is false. Right, next, false or not T implies F. Not true implies false. So if we do one at a time, not true, it's going to be false. Right, for sure. Now we just have this. So false implies false. Well, if we start with false, doesn't matter what it implies to, it's always true. So in here, it's going to be true. And then we have the false or true, because this is going to be true. Right? So we have the or, and in this case it is or false or true is going to be true. Right? The or is false if both of them are false. So we only have one of them is false. So it's not going to be that. Right. So next we have true implies false and true. Well, false and true. This is and. The and statement is only true when both are true. So they are not true. So we start with false. Now we just have true implies false. Well, that operation we discussed before, that can be false. So that's pretty much what we have. No true table. Just have one scenario. So in this case, so 3 implies whatever that is. True implies false is going to be false. Everything else is going to be true. But in this case, we do have true implies false, so it's going to be false. So once again, the implication is false if we have true implies false. Everything else is true, so we don't have that here. And finally, we have this false or true. False or true is still true. Then we have complement and then true. The complement of true is going to be false. So this in reality we have false implies true at the end. Now, if we start with false, false implies anything still true. So the answer at the end is still true. So once again, the negation or the operation, negation, and then conjunction or disjunction, and then conditional or biconditional. So that's the order operation that we follow as well. So to summarize what we have in this section, negation, we have a true to false or false. If it's true, I mean not true, it's false, and not false, it's true. Well, that's easy. The or, sorry, P or Q, P or Q, it's going to be false if both of them are false. False or false are false, or else are true. Next, this true and true have to be true, or else are false. Right? So it's true and true is true. Everything that is false. False or false is false. Everything else true. And then of course we have the negation. Right. Anyway, with that, we finished the note for section 3.4 and 3.3. So wait, thank you for watching, and see you in another video in Math 1332.